Example 6. In example 6, we want to evaluate the integral cotangent of 7x dx. Well, right off the bat, we look at this problem and we go, oh crap, I don't know the integral of cotangent off the top of my head. But that's okay, because we can do something in order to make this a little more friendly to integrate. If you don't know any functions whose derivative is cotangent, we can always use a trig identity. So we know that cotangent of x is equal to cosine divided by sine. So we're going to use that identity to solve this integral. So you get that this integral is equal to the integral of cosine of 7x divided by sine of 7x dx. So now the problem is that we need to use a u sub because this is way too complicated. So I'm going to let u equal sine of 7x. I'm doing this because I noticed that I have the derivative, which is cosine, up in that numerator. The reason I don't choose cosine is because if I chose cosine, the derivative is sine, or negative sine, and I only have 1 over sine, not sine in the numerator. So we let u equal sine of x, we get du is then equal to cosine of 7x times 7 dx. This piece comes from the chain rule. And so the problem now is I don't have a 7 in my integral. I only have cosine 7x dx. This is the only piece I have. So I need to get rid of this 7 over here. So I go ahead and I divide both sides by 7. And I get 1/7 du is equal to cosine of 7x dx. Now notice that this matches perfectly. So then I can rewrite this as the integral of 1 over u times 1/7 du. So I'm going to bring the constant out. I get 1/7 the integral of 1 over u du. And this is going to be 1/7 times ln of the absolute value of u plus c. And then I put the u back, I get 1/7 ln the absolute value of sine of 7x plus c. Now there is a reason that I cannot get rid of the absolute values, and that is that I'm not sure if x is positive or negative. If I knew for a fact that x was going to be positive, like for example if it was x squared, then I could drop the absolute value bars. Okay, here's another one. The integral of tangent of 3x dx. So I want you to try this one on your own. Try to be clever about how you u sub. Think about when you take the derivative where the new function is going to be. Alright, let's see what we got. So first of all, I know that tangent's equal to sine over cosine. So I'm going to get this becomes the integral of sine of 3x dx divided by cosine of 3x. And then here's where I need to do my u sub. I'm going to let u equal cosine of 3x because cosine's in the denominator. Notice that I erased a dx from right here. I don't know why I wrote it there. It shouldn't be there. So we take the derivative of both sides. You get du is equal to negative sine of 3x times 3 dx. So I'm going to get 1/3 du is equal to negative sine 3x dx. I'm going to multiply both sides by -1. And I get negative 1/3 du is equal to sine of 3x dx. Now this matches perfectly with that. So now I'm going to plug in my u sub, and I get negative 1/3 the integral of 1 over u du. This is going to be equal to negative 1/3 ln the absolute value of u plus c, which is negative 1/3 ln the absolute value of cosine 3x plus c. If you're rusty with your trig functions, I really recommend you review those for a bit, because we're really going to use those later in this chapter.